Number 9, the diagram shows a prism with a rectangular base ABFE. The cross section ABCD is a trapezium with AD equals BC, AB equals 8 cm, GH equals 5 cm, BF equals 12 cm, and angle ABC equals 70. Calculate the total surface area of the prism. How many faces do we have in this prism? We have 6 faces, 2 trapezium, and 4 rectangles. If we start to find the area of the trapezium, we have base 1 equals 8, base 2, because HG equals 5, so D equals 5, so base 2 equals 5. Now we need to find the height between them. We don't have the height, but if we drop perpendicular from C and perpendicular from D, we have rectangle. So if this 5, this also 5. Now you can deduce that this distance and that one equals 8 minus 5 divided by 2. 8 minus 5, 3. 3 divided by 2, 1.5. So this distance 1.5 and that one also 1.5. So 1.5 centimeter, 1.5 centimeter from symmetric. Now we can find the height. In this triangle, we have this angle 70. We need to find the opposite, and we have the adjacent. So using tan, we can find the height. So tan 70 equals h over 1.5. So h equals 1.5 tan 70 equals 4.12 centimeter to 3 significant figures. And also we can find BC. Now we have the adjacent and we need to find the hypotenuse. So cosine 70 equals the adjacent 1.5 over the hypotenuse, which is BC. So BC equals, you can switch between cosine and BC. So 1.5 over cosine 70 equals 4.39 centimeter to 3 significant figure. Now we can find the area of trapezium. Area of trapezium equals half base 1, which is 8, plus base 2, which is 5, times the height, which is 4.12, equals 26.8 centimeter square. And we can find the total surface area. So the total surface area for the prism equal to trapezium, so 26.8 times 2, and for the rectangle at the bottom 12 times 8, so 12 times 8. Then the rectangle at the top, which is 5 times 12, so 5 times 12. And the two rectangles, this one and the opposite one, which is 12 times BC, which is 4.39. So 12 times 4.39 times 2, because we have two congruent rectangles, equals 314.96. So 315 centimeter square to 3 significant figures. B, the perpendicular from G into EF meets EF at X. So drop perpendicular from G to EF. So this X. show that EX equals 6.5. EX. Now to find EX, we have this 1.5 because this is the same like that one. So 1.5 from 8, so Fx equals 1.5, so Ex equals 8 minus 1.5 equals 6.5. Calculate AX. AX. If you join AX, so this triangle AEX, right angle triangle, because this angle 90, we have AE equals 12 because this 12, and EX equals 6.5, so AX equals square root 12 squared plus 6.5 squared equals 13.6 to 3 significant figures. Triple I, calculate the angle between the diagonal AG and the base ABFE. To find the angle between the diagonal AG and the base, the diagonal intersects the base at A. From G, if you drop perpendicular, this will be GX. And we need to find the angle between AG and AX. So you need to join this AG. And now this is our triangle. We need to find the angle between AG and AX. We need to find this angle. We can call this angle theta. So we need to find this angle. So we have the opposite. GX is the height. We have the height. And we have AX. So we have opposite and the adjacent. Then we can find the angle using tan. GX is the height is 4.12, same. And the adjacent AX equal 13.6. So theta, the angle, tan inverse 4.12 over 13.6 equals 16.9 to 1 decimal place.